stop sharing your screen so I can share my screen and we will be live in 2 minutes. In a minute, yeah. Could you just quickly stop sharing your screen?
Pooja, you're a
Okay, I
little
stopped
quiet.
sharing.
We are already on live, so I would like yes. Manashri, over to you.
Thank you, Pooja. Good evening, everyone, and a warm welcome to all of you on the third day of the series of webinars organized to observe the International Coastal Cleanup Day. These week long series of expert talks on the theme of marine pollution and conservation research to protect our oceans has been organized by United Way of Mumbai in collaboration with National Centre for Coastal Research and Ministry of Earth Sciences, Government of India. I will now briefly introduce about United Way Mumbai. United Way Mumbai is a part of 130 plus year old United Way movement engaged in nearly 1800 communities spanning in 41 countries across the world. Our mission is to improve lives by mobilizing the caring power of communities to advance the common good. We work closely with a network of 400 plus NGOs and a large number of corporates for the CSR programs, workplace giving campaigns, and other events. This includes designing of CSR policy and strategies, due diligence of NGO partners, program implementation, employee volunteering, impact assessments, and financial and programmatic reporting. Over the past 17 years, we have partnered with over 300 companies and over 1 lakh plus individual donors, investing close to INR 390 crores for community development projects. Our flagship programs have been largely in the area of civic awareness, health, safety, and greening. In addition to this, we have designed and facilitated large scale interventions in the areas of education, nutrition, and sanitation in urban and rural communities. We have 6 focus areas, namely education, health, safety, income, social inclusion, and environment. In environment, we have two major projects which we implement. One first is the Mission Mangroves, which aims to conserve and protect the depleting mangrove cover of Mumbai, and the second project is Clean Shores Mumbai, which aims to clean and rejuvenate our city shores. Under Clean Shores Mumbai project, we have symbolically adopted 7 beaches and have executed several interventions such as mass beach cleanup drives for citizens, students, and employee volunteers. We have also carried out beach beautification activities such as wall painting drives, installation of appeal boards, awareness campaigns such as Nirmala collection drives, post immersion cleanup drives, and also have been generating awareness among the younger generation on the importance of conserving and protecting our shores and the marine biodiversity. We have also complemented the efforts by municipal corporation in keeping our cities shores clean. We have also extended infrastructural support to them. This is all about Clean Shores Mumbai. For more details about our other projects, you can also log on to our website www.unitedwaymumbai.org or follow us on Facebook, Twitter, and Instagram. Today, with us, we are honored to have Ms. Danja Hoehn and Peter Kohler with us to speak on the topic of marine litter, turning the tide and Indo-UK program on marine litter and microplastic research. I will now briefly introduce our guest speakers for the expert talk. Mr. Peter Kohler is a senior marine litter scientist at Central for Environment, Fisheries and Aquaculture Science. He is the principal investigator and workpackage lead monitoring and evaluation for the Commonwealth Litter Programme. His background and research interests are in the development of autonomous monitoring and mapping of marine litter, where he has worked over 6 years in the use of machine learning, drones, and sensors in autonomous monitoring system. Our next guest speaker is Danja Hoehn. She did her PhD at University of Southampton, UK, on population variability of Aurelia aurita. She is now working at Centre for Environment, Fisheries and Aquaculture as a co-lead for Commonwealth Litter Programme project in India, and she also leads a team monitoring waves, water quality, and eutrophication impacts in UK waters. I welcome you both to today's expert talk. It is our privilege to have you as our guest speakers. Uh, I will now request Peter to start the expert talk. Peter, over to you. Thank you so much.
Thank you very much for that very kind introduction. My colleague Danja, I think, will just put up the slides for us when ready. There we go. Thank you, Danja. So thank you to all the team at United Ways Mumbai. It's a very impressive introduction, and to the NCCR, the Indian National Coastal Research Centre. So we're very excited here, Danja and I from Cefas, to talk about marine litter today on the International Coastal Cleanup Day and Week. In this presentation, we wanted to talk to you about all the problems, some of the challenges, and some of the myths, as well as some of the solutions around marine litter, and also share with you a bit about the work we're doing with the NCCR and the Ministry of Earth Sciences. So we're very excited to be here today, and delighted to welcome all of you who are viewing us live on YouTube as well. So I wanted to start. Go to the next slide, please, Danja. I wanted to start here. I think this is becoming an increasingly common sight amongst the world today, with litter set to increase, waste production set to increase by 70% by 2050 to some 3.4 billion tons. 3 times as much, unfortunately, of that will be in the developing world, where some think in the region of 90% of the waste goes to open dumps like the ones you see here in this image. So one of the biggest challenges here, if you go to the next slide, Danja, please. Globally, something like circa 70% of waste goes to landfills. 12% of that by weight is plastics. Now, this is problematic because if you look on the next slide, if you look at the comparison of waste lifespans, you can see that plastics can last hundreds of years, and these are the plastic objects. Once they break down into microplastics and indeed into the plastic monomers and constituent items, they can last up to 100,000 years in the environment. So very long duration contamination. And if we move on as well, Danja, and again, sorry, if we look at some of the what I thought I'd show you here is some of the kind of key facts around plastic. Since the beginning of time, mankind has produced 8.3 billion metric tons of plastic. Only 9% of that is recycled. So far, something like 70 to 80% ends up in landfills or environments. The often quoted 8 million tons leak into the ocean each year, but a recent report just released in the last couple of days estimates that in 2016, around 11% of all plastic waste leaked into the ocean. And that was something in the region between 19 to 23 million tons. And we find that of all the waste that leaks into the ocean, 80% of that is indeed plastic. So considering that every second breath we take is thought to come from the oceans, from the oxygen produced from the oceans, it's a very important aspect of our life, important for everyone. So thank you, Danja. So if we're looking at marine litter, it can be defined as anything man-made that's deliberately or unintentionally lost into the environment and making its way into marine systems, for example, rivers, streams, channels, and oceans, via many means, either rain, wind, surface runoff, all sorts of those, and sewage systems as well is another major input via rivers. And it's a thought that, as we've said, around 80% of that consists of plastics. And in effect, we could say that we're turning our oceans into our own rubbish dumps. Generally speaking, we can divide the plastics into two main categories. There are many more, but these are generally considered the main ones. So you have microplastics, which I'm sure many of you have heard of, and macroplastics, and everything above 5 millimeters is regarded as a macro. So you can see on the right here, you know, big bottles, cups, things you can see with your eyes, essentially. And micro is everything below around 5 millimeters in size. And those microplastics come as what we call primary, which are often used in manufacturing. So as you can see on the left, in the palm of the hand, there are some little plastic beads. Those are called nurdles, and most things in the world are produced from those little plastic nurdles. They go into molds, and then they are formed into plastic items that you see every day. The secondary source is what we call breaking down or fragmentation of bigger plastics. So when the macro big plastics become the micro little plastics. But it's a problem for all of us, as you can see by this next slide, as it respects no international boundaries. So it is really all of our problem. For example, in 1997, in this image here, the Tokyo Express was hit by a 1 in 100 year wave. It lost, it was a cargo ship, and it lost a cargo container containing nearly 5 million Lego pieces, ironically themed marine and sea themed Lego pieces. And they've been washing up on not only British beaches, but on beaches all over the world. So you can see in the bottom right, just off the picture there, there's some washed up in Galveston in Texas, and some washed up even in Australia in Melbourne. So really a global problem, and just one demonstration of how a leakage in one place can spread around the world. So why is this a problem? Why should it concern you and me? If you live miles away from the sea, you know, does marine litter matter to you? If you've never been to the sea, why should it concern you? I think because we are turning our litter into our ocean into rubbish dumps, it has unfortunately severe consequences for you and I, because as this slide shows, effectively eating our own rubbish in a manner of words. The plastic monomers and additives that break down into microplastics, they're found in a lot of marine species that we eat. So it enters the food chain, it gets concentrated up the food chain. Recently, it's been found in humans. We're still trying to study the physiological impacts on humans, but we know that for fish larvae and some mollusks, it can have serious impacts on growth and on predation and behavior as well. So if we go to the next slide, there are also some really unfortunate examples in that it damages the marine life that we know and love. On the right here, through entanglement, very unfortunately, a seal has lost its life, and a whale. On the left, through ingestion, we're seeing that as there's an albatross on the top there, which has a belly full of plastics. Literally, it's been eating the rubbish. It mistakes as prey, and the same with the fish in the bottom there. And this is becoming, the animal eats the plastics and then feels full, and so doesn't consume anymore. This slide again is an example of how it has impacts on living creatures and can cause them to suffer a lot. So in this case, this poor turtle has a straw stuck up its nose, and it's had to be removed, but it was expected to recover fully. And another example here is perhaps one that's a little less obvious to us all, is disease vectors and invasive species. So what we mean by that is that plastics, like you can see by this by these goggles here, can actually become a raft or a harbor for marine species and also pathogens, so diseases. Although more work needs to be done about how that transfers, if the diseases do indeed transfer from the plastic objects. There was a recent study in 2018 in the Asia Pacific region that found that when you overlay plastic waste and coral reefs, that the likelihood of disease from those plastics increases from 4% to 89%. And considering that the UN Food and Agriculture Organization in 2016 believes that there's a shortfall there'll be a shortfall in seafood production by something like 28 million tons by 2050. Aquaculture, which is the food that we gather from the seas, is going to become an increasing food source for us all, so that any contaminations, any damage to that has potentially serious consequences for us in the future. And then it also has a human impact. So plastics chokes our beaches, chokes our rivers, our sewers. I'm sure many of you have seen this. And especially in flood events, so in monsoon seasons, that creates water backlogs, that creates flooding, which in itself can cause disease. This is a picture of a child in Vanuatu, unfortunately, with some litter dump back in 2010. Not only that, plastics in our waterways and in our sea can damage us financially, and can even be fatal. So the plastics can damage any economic activity that relies on the ecosystem. We call these ecosystem services. And in 2011, it was believed that plastics caused a 1 to 5% decline in global marine ecosystem service delivery, which doesn't sound a lot, but globally that's something like 500 billion to 2.5 trillion US dollars in cost, in benefits derived from those marine ecosystems. In Europe, for example, we believe it will cost around 600 million euros alone just to clean up to the EU's fishing fleets through the damage caused by nets and entanglement and lost catch. And indeed, in 1993, off the west coast of Korea, a ferry became entangled in a 10mm nylon rope. This coiled around the propeller, as you can see in this picture on the left here, which caused the vessel to suddenly turn, and that led to it capsizing at the cost of nearly 300 lives, unfortunately. So there are really serious concerns about the damage that plastic could do, and in that way it affects all of us, no matter how far we are from the sea or how high up we are on land. So what does the future bring for us? So far I've painted a very worrying picture of it, as I'm sure you'll agree. What can we do about this? I think we have to start with making it clear that it's a growing problem. It's not going to go away. If we ignore it, if we bury our head in the beach, in the sand as it were, it's not something that will disappear overnight. Since 1950, plastics production has seen an exponential growth to something like 1.8 billion tons by 2050, potentially. At 2011 levels, again, each ton of plastic cost around 3,300 to 33,000 US dollars. Considering current commitments, 53 million tons, even if we do everything we're doing today, 53 million tons will enter the ocean per year by 2030. So we really need to do more. And we're going to talk to you today about what we're doing and what you can do as well to prevent this becoming a reality. But before we do that, we need to understand what is science and what is myths. And unfortunately, there are quite a few myths about plastics out there. There are perhaps a little bit, it ranges from outright myths or fake news to not so quite accurate described. So I just want to talk to you about some of them today. And if we go on to the next slide, thanks, Danja. If we look at biodegradable and compostable plastics, everyone talks about these. Biodegradable basically is that it breaks down in industrial settings. So for example, an industrial composter, which has temperatures up to 70 degrees, can break it down. That biodegradable is when it breaks down in the environment. Compostable means it needs a compostable, something like in your garden or an industrial setting to compost it. There are varying standards to these. So and varying definitions as to what is compostable, what is biodegradable. The science is still out on some of the biodegradable items. There's been found that some chemicals mixed with those biodegradables to help them degrade are actually can be toxic in the environment. And also, when you introduce it to your waste management system, you create a brand new waste stream that can cost more money to manage, and it becomes more difficult to separate from normal plastics. So these are all problems that need to be considered. So it's not a panacea. There is no miracle cure. Other examples we can see there's a recent article around worms eating plastics, shoes which can be remade from beach plastics, enzymes that break down plastics, and biodegradable bags. Whilst these are all interesting and potentially useful solutions, it is really the kind of root cause that we need to tackle here. And if we go, which is our relationship with plastic. So is plastic bad? Is it evil? Evil is quite a strong word, but is it bad? It's a resilient material. It's relatively cheap. You can make many good uses of it. So in aviation, it's lightweight, it's durable, it's long lasting. In the space industry, in some medical applications, it can be very, very effective and a very useful product. When you compare that to perhaps not so good uses, so we can see here polystyrene food containers, drinks bottles. These are things that you use maybe for a few seconds and then you discard them. And as we saw earlier, they last in the environment for hundreds of years, potentially even tens of thousands to hundreds of thousands of years. Chief amongst those, as I'm sure many of us are familiar with, unfortunately now, are single-use COVID masks. Now, there is no reason why you couldn't have a reusable mask, as long as you're very careful how you use it and you use it properly, so you don't cross-contaminate yourself by touching the breathable area, for example, when you remove the mask or when you wash it. But we're increasingly finding COVID and COVID-related PPE in the environment. There's been like a 20% increase in takeout food containers as a response to COVID in the environment as well, globally. So what can we do about it? What are some of the solutions, and what is Cefas doing, helping to do, what work is Cefas doing for this globally and with India? I think the first thing to realize is that it's a complex problem with many pathways for how litter gets into the environment, all of it tied into our day-to-day behavior, the decisions we make as individuals each day, as well as the companies and the governments involved. And this diagram just demonstrates some of the complexities around that. But moving forward, perhaps, is redesigning our relationship with waste, rethinking our relationship with waste, so it no longer becomes an issue. Because as you all know, if you talk about waste or litter or rubbish or trash, it all comes with negative connotations. But I want to challenge you to think about that. Sorry, next slide, Danja. Yeah, thanks. I want to challenge you to think about rethinking that in terms of it as a resource. And this is where kind of circular design and economics come out. So something like designing out waste. And for example, the majority of waste that we see in landfills, and that is plastic packaging of some description. And sadly, after short use, around 95% of that is thrown away. 95% of that value is thrown away at a cost of something like $80 to $120 billion a year. So that's a vast resource that we're literally throwing into the rubbish bin. You can see it as literally throwing money away. So looking at those circular economies, and there's been very positive movements in that direction around the world. But as we've seen earlier, obviously more needs to be done. Another key element is waste management. Focusing on those hierarchies, and I'll talk a bit more about that shortly, but reducing, reusing and recycling materials, minimizing the amount of waste that ends up in our landfills is very important, because it also helps reduce the waste that leaks into the environment through mismanagement. And if we go to the next slide, Danja, it's also policy. across all stakeholders. So it's not just one stakeholder's responsibility to fix this all, it's all of us. So that's governments, it's you and I, it's scientists, it's research institutes like ours and like many around the world. It's the private sector, it's companies, NGOs, everyone. It's all of our collective responsibility, and coordinating our efforts is a very important part of that picture, to make sure that any work we do has that, maximizes that value by preventing or removing litter from the environment. And at this point, I'll hand over to Dr. Danja Hoehn, who will talk a bit about the work that her and a colleague, Dave Sivier, is doing in India, and a bit more about what Cefas is doing in general around marine litter. So thank you very much, everyone. Danja, please do take over.
Thanks, Pete, and thank you very much for this opportunity to present here today. And as Pete already said, I will talk to you a little bit about Cefas, about marine litter, and about the Commonwealth Litter Programme. So what does Cefas do? So Cefas is the Centre for Environment, Fisheries and Aquaculture Science. It's a UK government organisation, and we have large scientific expertise across a diverse set of marine topics, such as ocean processes, ecosystems, marine biodiversity, and climate change. The core aspect of our work is the scientific evidence and advice we provide to the UK government. So government policy on marine litter. We work with a number of government organisations, and as you can see in this picture here, science is not always straightforward, but we do try our best. We have a long history of marine litter at Cefas. We have 30 years of experience. There's a team of 10 experts with a diverse set of scientific expertise working regional and national marine litter programs. We've published a number of scientific papers, and we provide evidence and advice to the UK government and regional and international organisations. With CLIP, we monitor and assess levels of macro and microplastics in biota and sediment to inform action plans in Commonwealth countries. We're involved in researching biodegradable fishing gear and microplastic screening, and we're also involved in autonomous monitoring systems for marine litter. We're keen to share our knowledge through training on micro and macroplastic sampling and analysis. We also produce outreach material for the public. This is the Commonwealth Litter Programme, short CLIP, and CLIP is led by Cefas, and this is funded by the government's Department for Environmental, Food and Rural Affairs, short DEFRA, since 2018. And the programme works in partnership with countries across the Commonwealth to take action on plastic entering the ocean. This is just a short video to show you what we're doing, CLIP. Commonwealth Clean Ocean Alliance, short CCOA, was initiated between Vanuatu and the UK in 2018 to tackle marine plastic pollution. All Commonwealth countries were invited to join to pledge action on plastic pollution, with the aim of banning single-use plastic and banning the scale of microbeads. CLIP is part of CCOA and supports CCOA objectives of preventing and reducing marine litter. There are currently about 34 CCOA members, and that's about half of the members of the Commonwealth countries. And there was a really good buy-in from the Pacific nations. The CLIP is a programme to support Commonwealth countries to take action on plastic entering the ocean, to share experience and find solutions to environment and socio-economic problems caused by litter. The programme is working in the South Pacific, Caribbean, Asia and Africa. These are the 5 themes of CLIP we're working on. We're trying to prevent litter entering the ocean, and we're trying to remove it from the environment. We do some outreach activity. The other thing we do is beach monitoring. So we do look at the types of litter we find and the differences between the sites and where the sources come from. We need more information on microplastics because there's now evidence that it's found in every ecosystem in the Arctic. Microplastics are small particles, more than 5 millimeter, and when ingested with marine organisms, it can be a carrier of a harmful contaminant. And it's FTR analysis that can help us to identify which plastic it is. And therefore, we can then find out about the sources to tackle the plastic pollution. So FTIR produces a spectra of particles, which can then be compared to other spectra within a polymer library. We also do training of local staffs. FTIR is an effective way of identifying polymers, but we do really need to follow standardized protocols of research and monitoring to be able to compare these results in a meaningful way. These are the countries that CLIP has worked in the past: Belize, South Africa, Solomon Island, and India. And as you can see in the pie charts, when looking for litter found on the beaches, plastic was by far the most common item found. So what we did in Solomon Island, did some beach cleaning. And what we first do is when we collect the litter, we separate them into categories. We count them, we weigh them, and we follow OSPA method. There are different types of litter. We look at how many different types there are. For example, glass, plastic, bottles, wood, cosmetics. And we found items specific to each country. So for example, for Solomon Islands, this was camping stove gas canisters or plastic ice cream poppers. We could even identify products that were just bought in a local shop. For example, the foam noodle pots. And when we identify these items, it helps us to assess sources. So for example, are they coming from fishing or are they land-based? To make it scientific, we follow a specific structure. So for example, we look at a 100-meter transect on a beach and we follow a specific protocol. Sometimes these protocols have to be adjusted to each individual country, as I said, because they have individual items. In the Solomon Islands, 6 sites were monitored. A total of 8,439 items were found. There were 8 monitoring events between November 2018 and January 2019. And again, the biggest percentage of items found was plastic. And a colleague of mine has published a study on the microplastic. Here are the 2 studies have been recently published within Cefas by Kiet al and Hoetema. One of them is on microplastic in Vanuatu, Solomon Island, and the other one is a study in Oman. So today, now I'm going to talk to you about CLIP India, what we did in India. We did some beach monitoring in Pondicherry. In Pondicherry, we joined the NCCR scientists to do some beach monitoring down on the East Coast, and NCCR scientists have even done more of these beaches. We went to our beach and Paradise Beach. This is the CLIP team and the NCCR scientists doing some beach monitoring. And we were sampling meso microplastic using the quadrant method. All 3 categories were monitored: micro, meso, and macroplastic. Quadrants were taken down to monitor plastic in the first 5 centimeters of sediment. We also took some sediment cores to look at the history and vertical distribution. We also collected macroplastic. Found were a lot of shoes, specifically flip-flops. It's quite interesting because this week a study was published by the University of Oxford in the Seychelles, and also they found a lot of flip-flop items. Some of you might have been out on the beaches this coming days doing some volunteering work for the monitoring, and this is what we do in the UK. We also monitor beaches with the help of volunteers, and this is mainly done by the Marine Conservation Society. Some of these sites are cleaned and monitored monthly. In the future, we would like to continue our collaboration and partnership with NCCR, our host institute. We'd like to continue our work on the source and sink work, using the microplastic pump, doing some more seasonal water quality sampling, along with microplastic sampling, and doing some beach monitoring along the coast. You can see some Cefas scientists using the microplastic pump, and this is currently with NCCR collecting some samples. Here are some outcomes from the CLIP work, from our work. So CLIP supports countries across the Commonwealth, and we've been to countries like Belize, Solomon Islands, South Africa, and Vanuatu. And already we have developed 3 national marine litter plans. 4 microplastic laboratories have been set up in these countries. And as a result of CLIP research, Vanuatu announced a ban on 6 single-use plastic items. And in January, Belize passed legislation to prohibit the use of a range of single-use plastic and styrofoam items. Now I'm going to hand back to Peter, and he's going to talk to you a little bit about what you can do.
Thanks, Danja. That's it's a very some very interesting work in India there in comparison to other studies in the region as well. So what I wanted to talk to you all about today is what can you do? So you've seen what the problem is. You've seen work that scientists can do. Often, you know, you can be forgiven for thinking it's a huge problem. I'm just one person. What can I do about it? What impact could I possibly have on this huge global problem? And I think the answer is yes, there is a lot that you can do. And key amongst these is perhaps, in the simplest messages, perhaps focusing on the 3 R's: reduce, reuse, recycle. So for example, with reduce, just thinking about your day-to-day habits, looking at what items can you do without that are single use, that you use for a few seconds and throw away. So that's plastic bags, straws, where appropriate. Again, we have single-use face masks, if appropriate. Ideally, it's reusable and washable ones. Again, handled properly and appropriately. Reusable coffee cups, if you use them, and bringing your own food containers wherever you can as well. If you look at the next one down is reuse. So if you can't reduce it, try and reuse it. So that's reusing bags. If you're going about and you're going to use cutlery and you're going to eat out, perhaps bring your own. At least you then know it's hygienic and it's clean. Another one is reusable nappies and reusable plastic water bottles and refillable containers as well that you can refill. And finally is recycle. Recycle whatever you can, wherever you can, and ask to make sure you can recycle it. Ask your local authorities if you can, and speak to people. One of the reasons perhaps this is at the lowest end of the 3 R's, when perhaps you might think it's one of the higher at the higher end of the 3 R's, is that with recycling, a plastic bottle can only be recycled a limited number of times before the quality of that plastic degrades to the point where it can't be used again in a plastic bottle. And at that point, it usually either ends up in a landfill or it will be incinerated. So really, it's about reducing and reusing wherever possible, and then recycling whatever is left over. Finally, is sharing the message. And I do apologize for that picture of me. It's communicating the issue, and the reason why that picture is in there is because I just mentioned to a friend about a company that wouldn't refill my coffee cup. That got picked up by a local newspaper, which then went to national press, and as a result, the company changed its policy on refilling cups on trains. So just a little action like that can go a long way, and sharing it on all. And having those conversations in person, in your local school, in your local community, sharing the awareness of it, sharing that something really needs to be done about plastic pollution for our health and for our children's health and future. And the last slide on this is behavior change, because in a way it all boils down to our behavior, the changes we need to make to it. And the reason why there's a giant cargo ship there is because these ships are very hard to turn around. It takes a lot of energy to move it just a tiny bit, but over time that will increase and the momentum builds, and that's really how we've got to look at it. So even though it doesn't feel like you're doing much, just keep doing it, just keep going. I think on an individual level is a very important message, but the change also needs to happen at political, at scientific levels, in boardrooms, in companies, in NGOs, really thinking about how we can improve our relationship with the environment and improve our relationship with waste, and reducing it and reusing it wherever we can. So finishing up on three, maybe a little bit more than three key messages for you to take away in, of course, a reusable bag, it's a challenge for all of us. It doesn't respect any boundaries, it doesn't respect any class, it impacts all of us. It's in some degree directly or indirectly. And this is a picture of a beach in the Solomon Islands. This community was assailed by, thanks Danja, this community was assailed by plastic after the rainy season. I'm sure many of you might be familiar with this. Huge amounts of plastics then wash up on beaches, which spreads disease. It's a health hazard. So it is really a challenge for all of us. It starts with you. So this is some clip outreach in Belize. Here we spoke to some children through a local NGO, and through the Scouts Association over there, and we were delighted to see that the children started to ask more questions and started to challenge their parents about how they use plastics and how they throw things away in their waste habits. So it's very important, that aspect, as it starts with the individual. Also looking, we need a new sustainable relationship with plastics. We need to reduce those single-use, wasteful uses of plastics, to reduce it entering into the environment, and to also save us money and to become much more efficient economically speaking, as well as health-wise, as well as environment-wise as well. And it's not too late. If you go into the next slide, thanks, Danny. It's not too late. Action starts now. As we've seen, we need to do more, but we can restore that balance, I believe, in the long run. And with that, I just want to thank you all for listening. Thank you for United Ways Mumbai for hosting this event, and to NCCR and the Ministry of Earth Sciences for collaborating with us on this very exciting work that Danja and Dave have done in India. So thank you very much.
Thank you, Peter, and thank you, Dinah, for giving this expert talk to us. Peter, definitely the pictures which you shared were very powerful and very sensitizing. The earlier pictures which you showed, it had, I'm sure each one of us, they were equally disturbing, because that showed that how our actions are responsible, are harming actually the marine animal, the species out there. And it is not only harming the marine species, but it is also equally, it has a similar impact on our health and on our coming generation as well. So the very correct message which you gave, that we have to the behavior change has to be started from our end, and though it is difficult, but through small steps we can certainly achieve that if we collectively come together and work on it. By obviously by the 3 R's which you mentioned about reduce, reuse and recycle. And of course one more R I would like to add is rethink before buying plastic, before opting for any plastic material. Plastic is not harmful that way, but yeah, we can choose the products which we buy mindfully, so that it about what impact does it has on the environment, thinking about that. So definitely I would like to thank you and Dinah as well for giving for informing us about the about Clip India and about CCOA. and obviously about introducing about the Center for Environment, Fisheries and Agriculture Science, what you do, what your work actually does. So thank you once again. We would quickly move on to the question and answer sessions. I would like participants to drop in their questions which they want to ask Peter and Danja in the chat box. So Pooja, do we have any questions for them, for our
Yes,
guests?
Manashri, we
Yeah.
have started receiving questions. So I would like to read out the question to both of you, Peter and Danya. And for that, I would like you to, just stop sharing your screen so our participants can see you while you're giving the answers. So my very first question is that from the audience that we have received that what are the marine impacts on the marine litter economic if high litters in the oceans? So what are the risk factors into the environment and the human on the human because of the excess amount of plastic? So
I can answer that, and Danya, happy for you to chime in if there's anything you'd like to add. So, what are the risk factors for plastics in the ocean? I think you can look at them in terms of health, in terms of economic, and in terms of I guess mental and environmental in terms of ecosystem damage. So in those three areas, you can then if you then look at the economic impact. So for example, in the presentation that I presented, we mentioned a figure around 2011 levels. It's a very difficult thing to quantify the ecosystem's damage. It estimated that per ton at 2011 scales, so it will have increased by now. You're looking at a $3,300 to $33,000. So the damage done in lost productivity from those ecosystem services globally. That accounts for a 1 to 5% drop, which is up to 2.5 trillion. Now it's very hard to quantify that because of the complexities involved in it and that, but that estimate is at a base kind of level. It's just the plastics itself that does that damage. It doesn't take into account, for example, the onward damage to, if a tour operator loses its boat, that means less tourists come to that area perhaps, which means that there's less income from hotels, it's less and so on. So it's a knock-on effect. And because economies are so interrelated here, and the ocean is we're seeing through the blue economy movements and circular design, circular economies, the ocean is becoming a very important economic resource for the globe, and more important is the sustainable relationship of that, and that in itself is challenging. In terms of health, as Danja and I have mentioned, microplastics, when they break down into tiny little fragments, plastics break down in tiny little fragments, they can absorb, shall we say, or absorb contaminants. So that's inorganic pesticides or organic pesticides. It's the flame retardants that are often mixed with the plastics. It's the other additives. These are all proven to disrupt hormones and that's what we've kind of seen, at least evidenced in the lab tests of reduced reproduction of some marine fish species and bivalves, for example, in particular. And if we eat a bivalve like an oyster, we tend to eat everything, including its intestines. So we are, in that case, we're literally ingesting plastics. And recent studies have found microplastics in human organs and human tissues. We still don't quite know what kind of impact that's happening. It's still being studied, but it's obviously a big cause for concern. And then in terms of the ecosystem as well, it can transport, as we've said, diseases. So you saw that mask with all the little shells on it. Some of those could be invasive species. So what that means is that creature from one place is transported on this plastic raft, which obviously, because it's plastic, can float and move for great distances because it's so durable. And then that can drop that creature off somewhere where it's not been before. That then it grows and multiplies, and then it outcompetes the local species, which then can damage any ecosystem services like fishing, like tourism, that relies on those. I don't know, Danja, is there anything you want to add to that?
That was a great summary, Pete. I totally agree with the health impacts that we're not really sure yet what health impacts it's going to have on us. We need more studies in how plastics can affect us, because I don't think we have enough information on this yet. But by the look of it, this will be more becoming a problem as more litter enters the ocean, and these microplastics will then start coming into our food chain. So it's definitely a good place to do some more research, I think, in the future to find out how this will affect us.
Thank you very much for that answer. The next question is that we cannot recycle all the plastic after a certain point. Also, the biodegradable plastic can degrade only in the laboratory condition and not in the environment. So then how do this recycle, reuse and reduce concept will work? So
that's a very good question. I think there are challenges around the biodegradable plastics as outlined. It's mainly around standardizing. So there are some that break down quite readily. It's also how they break down, what chemicals they use to break down, and there's no international standards on that. Well, there are some being introduced here, but they're kind of at the early stages. So it's very important to standardize that, to agree what is biodegradable, what is compostable. That would include definitions of how long, how much time it takes to then degrade in the environment, what conditions it requires. But it's a very good point in that quite often it requires certain conditions, and often when it ends up in the sea, those it doesn't. A lot of standards don't, or a lot of biodegradable plastics, for example, may not break down in the sea. And in that case, they act very much like plastics. In terms of the reduce, reuse, recycle, and rethink as well, I think they're very powerful. They will work. There are other waste management as an industry is looking at this challenge and is looking at different types of recycling, chemical recycling and mechanical recycling. Obviously, the simpler it is for them in terms of materials, in terms of use, the easier it is for them to then treat and recycle that equipment. So it's very important in that time, in that context, to have that integrated approach to it. You know, the waste management cannot do their work alone. They need the help of the product designers. They need the help of you as the public, and when you sort your waste and when you clean it. But it is not, there's not one person, I think, in my opinion, that is responsible for all of this. Each one of us are, and we each have to play a role. So and we've talked about some of the roles that you as an individual can do, but also some of the roles that scientists and politicians and companies have. So we all need to work together in that respect. Danja, anything you'd like to add to that?
Yeah, it's obviously a very complex problem we have and we face here. But as Peter explained, I think it's also down to the product designers to make changes, and we all have to find different products instead, to not have all these plastics, which we maybe or might not be able to recycle in the future. So it's a huge challenge for, I think, the whole globe to actually find different materials to use instead of plastics. Obviously, there are areas which is very important, as Pete outlined, in aeroplanes and medicine and stuff like that. But there's other things like food containers or plastic bottles, which I think is really important that we start rethinking and using other products, or even starting to reuse our bottles and use our plastic containers, or take our containers to the shop, as this might already be happening in some places. As Pete explained, he took his cup to the coffee shop and wanted to refill it and things like that. I think if we do this more in the future, everyone can play a part and we can all make a difference.
Thank you very much. And that's a very nice answer, that we need to look for the recyclable, reusable items, that we really need to work hard on working on those protocols. So the next question is that what are the key policies aiming under the London Protocol against the marine litter?
I think it's important that we look at those key policies. So things like looking at extended producer responsibility and circular design and those sorts of things to reduce that waste and reduce the those elements of waste, of plastic waste, that I think contaminate and enter in the environment, and also getting countries to sign up to those protocols and abide by them and introduce them into their waste management structures, I think is a really important aspect of those protocols.
Sure. Also, along with that, there is a second question that Mr. Arvind is asking, that how does this controlling marine litter functions under the London Protocol? The functionality of the protocol.
It's quite an interesting question in terms of how. Oh, am I muted? No. It's an interesting question of how that incident works with the London Protocol, and how we kind of can introduce that into strategies to prevent marine litter. But it's something that I think we all need to work on throughout the industries and throughout the area. I mean, the role that Cefas does and the role that we do as scientists is really looking at what evidence can we provide to make those decisions and to inform better uses and the implementation of that protocol.
Okay, due to time constraint, we will only take last two questions. So the second last question is that the water scarcity is very, very high in India and other developing countries. So spending water on cleaning plastic and reusable things might create water scarcities in such countries. So what are the better options, that instead of recycling and reusing things? So what could be the better options, or how to tackle this problem?
Sorry, could you repeat the question? I had had a connection issue.
Sure. So the question is that the recycling or reusable things often takes excess amount of water, and countries like India and other developing countries, they will be facing water scarcities, including the climate change and global warming and etc. the situations. So in that case, what should be the sustainable way to mitigate these problems? Because one solution might lead to another problem. So how do we deal with it? So is there any ways?
In our experience, because it's a very good question in the sense that a lot of these problems are interconnected and interrelated, is to bring stakeholders together based on the science and the evidence that we produce, to then discuss what those solutions might be. And in that way, the aim is to try and mitigate impacts on other industries or other environmental factors around plastic waste. I mean, you can look at replacing. There's often quoted something like, it takes to produce a cotton bag instead of a plastic bag. It takes up something like 200 times more water, because you have to obviously water the cotton and that, and to grow it, to then weave it into a bag, whereas a plastic bag takes a fraction of that. So there are issues around that, but I think if you look at the longer term and the bigger picture, is that the plastic will stay in the environment and continue to contaminate the environment for potentially hundreds of years to come. And so I think it's important that we look at the problems holistically, and indeed that's what we tried to do in CLIP by addressing the land and sea-based sources around the London Protocol there, and as well as looking at how outreach and communication and underpinned by kind of scientific knowledge.
Definitely. So the last question we will take today, that is asked by the Raja Ram. How can we sorry, just a minute, I'm unable. So how we can micro plastic damage in marine environment, and how affected marine treated and take safety measures. So I think the person wants to ask that how does this marine plastics or microplastics affects this marine animals, and what safety measures we can take in order to prevent them.
So is the question, what safety measures can we do to prevent
yes, the damage that caused due to microplastics and the plastic waste dumped into the oceans.
Danja, do you want to have any thoughts on that?
Yeah, I think we need to stop obviously plastic entering the ocean, so animals will stop taking it up, but it's easier said than done. There's already a lot of plastic has entered the ocean already. But obviously what we're aiming to do is to stop this happening more and more in the future. So as Pete already showed in his slides, there's already a lot of examples of mammals as well as fish, as invertebrates taking up these microplastics. And some of that, we see like Pete's pictures when they end up stranded because they get entangled and then they die. Or for example, also I think there's been a report of whales and dolphin strandings, and they open up and they find that their guts is clotted completely with plastic, and they can't just take anything in, and that's how they die. Same with birds, marine birds. They start building their nests on plastic and ropes and stuff like that, and the chicks then hatch and start taking up whatever they find around them, and which they mistake for food, and they die that way. So yeah, obviously this is a huge problem, and I don't really think I have got a solution for how we stop the microplastic getting in these animals for now. But yeah, Pete, I don't know, do you want to add anything?
Yeah, I mean, I think those are all very good points, Danja. I think it's something where we've got to prevent it at the source. Really, it's tackling that source of it. And if I can go back to the London Protocol question about the implementation of it, I think a lot of that deals with the dumping of litter at sea, and although it's 20% of the litter comes from the sea, a lot of that comes from land, and preventing both of those occurrences from happening is very important, because that stops it from impacting marine life in the first place. Now, will there be a day where no litter escapes into the environment at all? I'm not sure how realistic that is, but I think it's incumbent on all of us to reduce that to as minimal levels as possible, and with the right solutions, the right technology, the right science, and the right willpower and action, I think that is very possible. And again, looking at some of the challenges around the implementation of the protocols, including the London one, it's all of the kind of world's most developed countries, say, have quite well-established port facilities to take on that waste. It's a largely unknown amount because these ships can dump out at sea where you can't see it, and we haven't really covered that too much in today's presentation. But looking at, through CLIP, we've done a lot of work on port reception facilities, auditing them to see how much they can comply with it. We found that in a lot of countries, the infrastructure is too costly. The technology it cannot be maintained locally. So we looked at regional action around that and encouraging sharing of information and also enforcement is very important. And in the Caribbean recently, a cruise line company, I think it was Caribbean Cruises, was fined up to $50 million US, I think it was, because they were caught dumping litter, shredding and dumping litter out at sea. So it's very important to work across land and sea to coordinate efforts and to implement those protocols based on the science as much as possible. And the reason why I say that is as though, you know, there are areas that we need to improve on. It's that common denominator. It's the sort of if there are disagreements and that to a certain degree, the science helps make the picture clear of that impact on the environment. And as your reader suggests, as the viewer who's put that question is, it is a very high impact area. So yeah, in short, I think along the lines of what Danja was saying, it's about coordinating efforts to prevent that and putting into law, international law, and signing into national law as well, which is also very important to adopt these protocols and to implement them in countries and to enforce them and to work together around that. So, for example, in the South Pacific, the Australian and New Zealand navies has been lent to some Pacific countries to help in that enforcement, because again, you know, you can ignore it, but litter doesn't respect any boundaries in the ocean. It goes wherever the currents take it and wherever the wind blows it. So it's very important that, like climate change, we all work together and we put in international frameworks and laws that are interconnected. A lot of them now, unfortunately, are not very well interconnected with each other or are signed into law. So I think there's a lot of work that international organizations and governments need to do, again, supported by the science, to build that evidence-led policy so we can make clear why we're changing and the directions that we need to head.
Yes, very well said, Peter, that it should be the coordinating efforts from the government, individuals, and all of us who are living on this planet in order to have a sustainable lifestyle. So now I think due to time constraint that we cannot take more questions. And I think more the questions we have been receiving are more sort of similar, that what should be the solution and how does it work, and about the 3R strategy. So I think we have pretty much covered during the session. And thank you very much once again for joining us and giving this insightful knowledge about the microplastics and about the sustainable ways. And I really personally loved about your refilling cup thing. So I think we should now make more efforts about it, because I also believe that it comes from the consumers. That when consumer demands the productions or the producers, automatically it will make changes, but it has to come from within, and the change action starts now. So yes, thank you very much once again on the behalf of United Way Mumbai and NCCR. We thank you both, Peter and Danja. It's been lovely to have you. Yes.
Thank you.
Thank you very much. It's been a pleasure.
Yes.
Thanks for inviting us.
Yes,
Thank you everyone for watching.